So currying. So currying in JavaScript is a concept, right? Which basically means that let's say this is a function, right? Join, it takes 3 arguments and it returns those 3 arguments just separated by underscore. So if I just do console.log join 1 2 3 and I run it, it should just give me 1 underscore 2 underscore 3, right? So this is a function. This is how you call this function, normal, right? Now if we curry this function, right? So if you curry this function, that means that you can now call this function something like this also, 1 2 3, right? This is also how you can recall. So this is basically called a curried function. So basically currying means that you take this normal function and you just decompose it into a series of functions that can take a part of the argument it originally took, right? So that also means that this is also a curried function. So basically if you just do this, this is also a curried function. Now why do we use this currying? So we need currying for a situation. For example, you have a really large code base and you have a really large code base and you're writing a function which is going to do a lot of things and it is going to take a lot of variables, and the thing is that for the function to work, the passing the first variable needs to be passed, and if it does not get passed, you should throw an error. This thing should not work. And you can technically do this with just writing a normal function and passing a lot of things in it, but the thing is that that will not be elegant, that will not be readable, and not easy to debug. So first let me just show you a brute force way to do it, right? So that you can know, like, okay, this is how it works, right? So as I discussed, this is a curried way of calling a function, right? So I've written this curry function, right, which is going to help me do that. But this is a brute force way to do it, because this thing will help me implement this, but it can't implement this. So I'll tell you how this works now. Okay, so first let me just show you. So what I'll do here is that I'll just make a curried version of this join functions. I'll just write this curried join because it is going to be curried now, right? So and then I'll just use this function I wrote, curry, and pass this join function into it. So now I'm passing this join function into this curry function, right? So it took it here, right? Now I have this curried join, which basically means this function. So as I passed it here, what was returned to me was this function a, right? Now what I can do is that I can just call this curried join, right? So this is actually means function a because it was returned to us when we did this, right? So this this should pass something into a, right? So into that a I'll pass 1, right? Now as we do this, and if we run it, imagine what will happen. This thing will be returned what? Function b, right? Because function b, right? Because when you're passing 1, it is going into this a, and then here it is returning it function b. So now this curried join 1 is actually function b. So now how do you call this function b? You pass something into this b, right? That would be my 2, right? And now once you do that, exactly the same way you get returned function c. So to call this function c, you need to pass something. So I'll just pass 3. So this is what a currying looks like, right? As we discussed, this is called currying. You are decomposing the function into a series of functions so that you can pass the arguments differently. So now I'll just print it, right? And if I just run this thing now, you should see 1-2-3, right? There you go. So that is basically currying. You just curried this join function, right? Now this is a very brute force way to implement curry, because if you see that if I try to pass this type of argument, so right, have passed this type of argument where there is not three different things, but in one argument I'm passing in one call I'm passing two arguments. This will not work here, right? Because when I call this basically expects another thing to be passed here, so this is basically not going to work, if I'll say, right? So how do you write a curry implementation that just works anywhere, right? So for that you have to use recursion, right? So let's see how you do that. Okay, cool. So I've commented this brute force curry function that we are understood. This function is actually a function which will just can curry anything you pass in any way, right? It uses recursion. I will tell you how it works. So here basically this is an example. Actually I can show you a bit easier to understand this. So I can pass 1, comma 2, I can pass 1, comma 2, comma 3, I can even pass any way I want. This is how currying is actually implemented. It takes this join again, and the fn is now join in this function, and it remains so in this execution because due to closures, right? But we'll not get into those. First we pass this join into this function, and now this function is returned to us. This function is named curried function. So now basically curried join, right? This curried join is basically equal to this curried function, right? It's the same, right? After doing this line, right? Now how do we how does this thing work? So if this curried join is curried function, it expects some arguments, and ... the args means that you are spreading this argument. Here I'm spreading this argument, meaning that I can pass anything I want, any amount of 1, 2, 3, or any amount of arguments I want to pass. So to call now, as this curried join is now curried function, which is this, so I can just pass something. So here I'm passing 1, 2. So curried join is equal to, as I said, calling curried function 1, 2. So now in this args I'm actually passing 1, 2, right? First, so just this part, right? So once the 1, 2 goes in, what I check here is that what is fn.length. fn.length means join.length, because fn is equal to join, because we passed it here. fn.length, basically join.length, is equal to 3, and because this dot length, when you do dot length to a function, it gives you the number of arguments it can take in, which is a, b, c, right? So this is 3. So here what you're checking is the number of arguments that I have passed is greater than or equal to this 3, because if so, right, if I do join 1, 2, that basically means that, hey, 1, 2, 3, that means that it is 3 arguments, and we should now just return this thing. And if it is true, that means that, hey, we have enough of a number of arguments that this function needs to work, and we will just call the function, right? But if it's not, which in this case it is not, because we are passing 1, 2, which is 2, and 2 is not greater than or equal to 3. So that means that, hey, the number of arguments is not enough, let's just go ahead. So this does not execute in this case, right? So then we go to this else statement. So in else, what happens is that first we return a new function. So what happens is that this curried join, right? This curried join is now equal to this function, right? This function, right? Now to call this function, as I said, now to call this function you need to pass something into this more args, right? So here we pass the next set of arguments, right, which basically here that is 3, right? So here we are basically passing 3, right, meaning this, right? That's what we're doing here, right? 1, 2 has returned this more args function, and into this more args we are passing 3. Now once we have passed this, so this basically means once you have passed this basically means we are returning this curried function again. And what is curried function? Curried function is the same as this function. We are recursing, we are calling it again within itself, right? Because we knew that, hey, this is not the full thing, so there are more things that can be passed. So in this function we'll call this function again to start this process whole again, this whole thing, right? So this is equal to this. So here basically the call is so I can just write here for more ease. So function we passed here 3, and here what happens is this curried function is called like this. So I'm spreading the arguments, we have all the arguments. So the args, as you remember, is 1, 2, 1, 2, and then I'm also including the more args arguments that we passed, which is 3, right? So this, so basically we are recursing or calling this curried function again within this curried function to just repeat this whole process, because you don't know that is this the whole thing, or we have anything else, or are we done to do this? We need to do this again, right? So basically we are using recursion. So now this guy is returned what? This thing, right? So we'll do this curried 1, 2, 3, and as this happens, this check, we do this check again. Is the function dot length, that is 3, less than or equal to args dot length, which now becomes 3, because 1, 2, 3. So basically now it gets updated to this. So this is 3 now. This is works, and then we just return a function and we pass all the argument. This meaning we do join, call this 1, 2, 3, and this actually executes this function, and this returns this 1, 2, 3. This returns 1, 2, 3. So basically this curried join returns 1, 2, 3, right? And that's what gets printed basically, right? So finally, as we are calling this, all of this is happening and it is ending right here. So now I've just changed the arguments again, and let's just confirm what I've learned. So in this case, so first in curried join, I'm passing 1 right here. I'm passing 1. This fails because 1 is less than 3, and then we go to else, and then I'm returned this function into which I am passing 2, 3, right? So I'm passing 2, 3. Right, and inside this I am actually recursing this curried function again, because we don't know what's next. So we'll just do this whole process again, and inside which I am passing the previous argument and the current argument. So basically 1 and 2, 3, which amounts to this. So once this is called, go through this again. Now 3, this actually is true, and then we just return this guy here. Join is called with 1, 2, 3, and we should, if we run, we should get 1 underscore 2, 3, 2 underscore 3. So that's all about currying. That's how you implement currying. I know it could be a bit not so easy to understand at first, but just take a paper, dry run it, and you will get how this recursion works, right? So that's it basically about currying.